Welcome to our cosmic journey where we will dive into the intricacies of our home galaxy, the Milky Way, and our neighboring giant, the Andromeda galaxy. Over the next 15 to 20 minutes, we'll walk you through a cinematic narrative that begins with a countdown to one of the most mind-boggling cosmic events, the collision of the Milky Way and Andromeda. Hey everyone! If you enjoy exploring the cosmos, please like, comment, and subscribe to our channel for more space adventures. In roughly 4 billion years, our Milky Way and Andromeda galaxies are expected to come together. Imagine a countdown clock ticking down billions of years, setting the stage for a cosmic ballet that will reshape both galaxies forever. Let's set the stage. The Milky Way and Andromeda are two colossal spiral galaxies. While they share many similarities as spiral galaxies, they have distinct differences that make our story even more interesting. In this act, we focus on galaxy formation. Milky Way's formation history involves multiple smaller galaxy mergers and a more serene spiral buildup, while Andromeda has experienced more rapid assembly phases and intense merging events. Dark matter. Both galaxies have mysterious halos of dark matter, but studies suggest variations in their dark matter distribution, influencing how stars and gas rotate within them. Stellar evolution. The evolution of stars in each galaxy might differ. In the Milky Way, stellar birth and death occur across an expansive disk with a diverse range of star populations, whereas Andromeda's star-forming regions indicate episodes of rapid, large-scale star production. To understand the vastness of these galaxies, picture this. The Milky Way is like a bustling city illuminated by thousands of streetlights, while Andromeda is akin to a sprawling metropolis, larger and even more intricate in structure. Or imagine comparing a standard dinner plate, Milky Way, to a slightly larger serving tray, Andromeda. Both are familiar in our everyday life, yet distinct in scale. As we zero in on the present day, modern astronomical studies have given us breathtaking real-time space visualizations and animations that reveal dark matter dynamics. Recent discoveries have refined our understanding of dark matter halos enveloping both galaxies, explaining why the stars orbit as they do. Think of dark matter as the hidden scaffolding that shapes a building. Though unseen, its presence is crucial for stability. Stellar evolution in action. Observations hint at regions where star formation is heating up or cooling down, revealing the life cycle of stars from their birth in nebulae to their eventual spectacular supernova explosions. These events are like fireworks in our night sky, each burst marking a new chapter in stellar evolution. Galaxy structure differences. By comparing the spiral arms, star clusters, and central bulges, you can spot at least 3 key differences: the rate of star formation, the distribution of dark matter, and the historical buildup of stars and gas. This side-by-side exploration gives us a better idea of how two giant galaxies can be so uniquely dynamic. Imagine the Milky Way as a well-planned suburban neighborhood where each area has its own charm, and Andromeda as a vibrant downtown district full of rapid changes and bursts of energy. These conceptual analogies make it easier to grasp the relative differences between these cosmic structures. Looking ahead into the future, we delve into exciting predictions about what will happen when these galaxies eventually collide. Cosmic collision. As we count down to the collision in about 4 billion years, computer simulations and animations show the intricate dance that will follow. This cosmic event will likely trigger bursts of new star formation as clouds of gas and dust compress together. Reshaping of stellar populations. The merger will mix stellar populations from both galaxies, giving birth to new regions of star formation, while older stars find new orbits in the resulting galaxy. It's like mixing two different recipes to create an entirely new dish. Dark matter reconfiguration. The enormous dark matter halos will interact in complex ways, potentially leading to changes in the gravitational balance of the new, merged galaxy. Think of it as two different support structures merging into one robust framework. Our journey from the origins of these galaxies to their destined future illustrates the dynamic, ever-changing nature of our universe. Recent astronomical discoveries continue to enhance our understanding, and every new simulation pushes the boundaries of what we thought was possible. Before we wrap up, here's a recap to ensure you remember three key differences between the Milky Way and Andromeda. Stellar evolution. They differ in their star formation histories and the life cycle of their stars. Dark matter dynamics. Variations in dark matter distribution affect the stability and rotation of each galaxy's components. Galaxy formation and structure. Each galaxy has a unique history of mergers and structure formation, influencing their overall shape and size. Thanks for joining us on this cosmic journey. If you had fun exploring the interplay of stars, dark matter, and galaxy dynamics, please like, comment, and subscribe. Let's continue exploring the wonders of our universe together.